Welcome. 10 years of microservices at FINN.no, and we still haven't slain that dragon. I'm very happy that the room is full. If you are tired of standing, there is an overflow area out, up the stairs, and around. And there you can zap between all the presentations going on. But here we are talking about dragons. As a new hire at FINN.no, someday you might have to submit code to our monolith. It's called IAD. It was developed under strict deadlines and scope creep in 2004. That can feel big, daunting, and scary. Where do I start? But with some experience, you'll understand that this is our tangled, fire-breathing dragon. And it's even tangled like spaghetti code is ought to be. But when you do become an expert and you know how to tame it, it's somewhat cute. And there is a reason why this has become our legacy. The system has given us a total revenue of more than 1 billion euro over these 15 years. So my name is Henning, and I've worked with FINN.no since 2004. I started working with Finn, developing the prototype for Finn Travel. I have been tech lead for the maps, and now I'm part of the architecture team, besides running Kafka and the map service. And I'm also on the board of directors currently. And my favorite evening activity, that includes last night, is reading stack traces and hunting memory leaks. So in case dragons was not sufficient to wake you up, we will do a short little quiz. And there are no prizes, so relax. But you might tell your friend next to you the answer if you know it. So what can this be related to Finn? The answer, a suggestion was test failures, and probably not. So at least in rural Norway, this is what the youth thought they were drinking last weekend. But from my point of view, this is the percentage of adults in Norway who has heard about FINN.no. And I assume that the remaining 4% does not have access to the internet. Start the year Finn was founded. Yeah, there was some rune inscription found up in Trondheim, but yeah, not yet a number of employees, luckily. I'm not managers either. But 10 years ago, we officially deployed 10 times a year, and we had 6-hour downtime during the night, and all developers had to be present at 6 o'clock in the morning. So this is the average number of verified artifacts in a week with 70% certainty. As this very clear graph shows, is that it varies a lot, but I found the peak to be 2,356, and the lower bound is around 800 during Easter. So quite a few deployments. To production, yeah. So this number is then the number of unique pods deployments running in production in Kubernetes right now. We have additionally about 40 applications that are not moved to that system. And this changes every day. I updated it 2 days ago, then it was 580, and last night it was 586. There is probably some kind of limitation how many deployments should you have per developer, and but we don't know what that number is yet. I'm sure we'll find out. So originally, when we started with what ended up being called microservices, we did sort of manual bin packing. We had 8 servers, and we allocated, okay, this one needs 2 replicas, and we will put it there and there in Puppet. So it was the very old way of doing it, but it was very efficient for us. We could deploy in 10 minutes a new service. But now we're on FIAS, which is a platform, or whatever you like to call it, built upon Kubernetes, more or less simplifying how to use Kubernetes for our usage. So are there someone who does not live in Norway here? Quite a few. NDC is usually an international audience. So then I'll mention that Finn is Norway's leading classifieds and marketplace site. So if you want to rent a flat, buy a house, sell your car, or get a pre-owned baby stroller in Norway, you will most likely end up at Finn.no. And it looks like many other marketplaces and classified sites. Here we have the recommendations, and Here is, you can buy an old house and renovate it if you want. So, this is kind of småbruk, the most popular category in real estate, not as in number of units sold, but as in traffic. So it appears that all Norwegians are dreaming of a small farm in the woods. So in 2008, a little bit more than 10 years ago, we had one single database. It was Sybase, which is Microsoft SQL Server is actually a fork of Sybase, or depending on how your point of view, of course, but it's similar. And a few years later, we introduced the principle that a service should own its own data, and we opened up for creating new databases. In these days, you had one enterprise license. It costs 2 million Norwegian crowns a year, so you couldn't really have many of them. But with Postgres, you could have more. So as of yesterday, I found 22 Postgres clusters, 128 schemas, 1,332 Kafka topics, which are rounded up because it's a nice number. We tag topics as private or public. A public topic is supposed, you can use the data, and it's supposed to be like an API. It should be stable, it should have a schema, etc. Whereas a private topic, if you are peeping into those and you are depending on it, it's your fault when it crashes. But the second last line, we still have the Sybase database, the legacy DB. So it's not turned off. So the outline of this talk is, where are we today, which we have covered now. What did we learn? What do we actually mean by getting out of legacy? It turned out I found 6, 7 different meanings around in the company. And the one thing I learned from Eric Evans about ubiquitous language is that if you use the same word in different meanings, communication is hard. We go through some major events, and I expect there is time for 10-15 minutes for questions if there are some non-Norwegians here that want to ask questions. We all know that Norwegians never ask questions. So 10 years of breaking up the monolith, and we still haven't found what we're looking for, probably. What were we looking for? I think we were looking for the glorious days of perfect software that did exactly as we wanted, with no technical debt, that we could change any day, elegant architecture, dream to operate, and which is never down. And microservices didn't solve that for us either. But we have gone quite some way. So currently, we target an uptime of 99.9% per month. And when we have the monolith, I think the uptime, we didn't measure it that well, but it felt like around 99%. So our target is 10 times better. And actually, year to date, we have 99.97% uptime. But of course, in such a complex system, uptime must also be defined. So we have defined 8 core business services that should be up, and we are waiting downtime according to traffic. So this is an artificial number, but very useful. Because some service is always down, but we are handling it with fallbacks or caches, and it comes back. And also last year we had 1,700 million NOK of revenue and about 40% profit margin. So it's in total the system works very well, especially for our owners and shareholders. But I think also for the users. FINN ranks very well on happy users. So to take the conclusions first, in case you have to leave for some food outside, what I've learned, and I think I'm going to make a t-shirt of this one. What problem are you trying to solve? This question should be asked more often, and we should demand a better answer on all levels, from the board to the infrastructure, when we want to do something. If the stated problem we're trying to solve is explicit, it's so much easier to evaluate a proposal and see if it is actually solving the problem. So what's the problem we were trying by breaking out of the monolith, eventually creating hundreds of microservices? Was it developer morale? Was it building our resumes so we look better on LinkedIn and get more headhunter calls every day? But actually, it was a feeling that it was hard to get anything done. When you have 80 developers in the same code base, oh, those idiots over there broke the build. Oh, you destroyed my branch. So we felt like we couldn't really often tell, oh, no, we can't do that because of legacy, it's hard, oh, you have to wait till next year. Originally, there was a structure, it was called three-layer architecture, which we today don't consider that much of a structure because you have all the horizontal dependencies tangling around. Most of the code was written in stored procedures in 2004, which is still possible to learn, but it's not fashionable, it seems. At least we don't have many developers who want to develop in stored procedures. And we also had a very slow build. Subversion up was a pain, and there was a whack-a-mole. In the times when we had 4 releases a year, you had 1 month of freeze before the release. We are stabilizing. Then we had a release night. Then we had 1 month of firefighting. And then you had 1 month of development. And then a new stabilization period where you have to call anything a bug fix to get something out, of course. And yeah, that was those days. No one really follows a deploy anymore. So, second thing, which I've reflected a lot upon, which Eric Evans told us. Not all of a large system will be well designed, but parts of it can be properly designed. And the trick is to figure out where do you need actually appropriate design. So we have to accept that we have ugly parts of the code and we would like to rewrite it, but since we're a business, we probably won't have time to fix everything. It's very hard to accept, but I think I am starting to accept it. So, out of legacy, what do we mean by that? So the way we as engineers and tech people, we talk about our legacy systems a little bit like this. Yeah, it's old, it's almost falling down, the roof is leaking. We should really do something to this old system. And if we really, really want to fix it, we say, oh, water is filling the floor. This is a catastrophe. We must fix it now. But then the product or business people, they might think that, it's expensive to run, but it's nice and it looks good and we earn a lot of money. What's the problem? There's usually a reason why a code base ends up as legacy, and that is it works for some definition of works. Typically that it earns money for the company. And it works because it was extended from something simpler that worked. But 10, 15 years of new requirements, sales guys that want to meet their quota and good ideas, it turns into something complex. Yeah, so what do we mean? What technical problem did it solve to get out of legacy? So I think everyone I talked to agreed to this one, that if you have to change the code and wait for deploy of the big monolith a month later, that's a problem worth solving in many cases, especially for a web-based service. Synchronous database call to a legacy database can also be problematic because you need to scale your legacy database and it might not scale anymore, or you can't make changes to it because everyone is depending, and if you don't know what happens if you change the table. And when teams have fixed these 1 and 2, they might move the target to 3. So we want to avoid, or we have synchronous calls to a service that calls the legacy database. So, every problem in computer science can be solved with another layer of abstraction. So here we have put something in front of the database, which you could argue it's another hop, so it's a waste. But on the other hand, it gives you the opportunity to actually encapsulate your database and over time change what's behind. And then we have some teams doing asynchronous dependency on data from the legacy database, so that we're not calling the legacy database, but we are depending on the data from it. So we are conforming to that model in DDD speak. And you could do that by asking a replica duplicate or consuming a stream. And if you remember 1300 Kafka topics, we're strong into consuming streams. And on a higher level of abstraction, you can conform to the model and map both ways. So if you are selling something on Torget in FINN, a used sofa, you are using our new stack. It's entirely new, running on 14 Postgres databases probably, and I don't know how many microservices. But it's conforming to the old model, as in we can sync both ways. So the data still ends up in the Sybase legacy database, which means that they can't change that much because it must still map. But one day when we're finished, they can cut that synchronization and they can do whatever they want. And we're getting more meta. You can have the same meta model but different fields. Or you can say, screw you guys, I'm going home, as they said in South Park, separate ways. There is no relationship. And I don't want to call this a maturity model, because that might imply that 7 or 6 is the best. And it might not be. So getting to the timeline. In 2004, which I mentioned in the opening, we rewrote what existed of Finn into something called IAD. It was in Java, stored procedures in Sybase, and a 3-layer architecture, and even 3 modules in Maven. But Finn started internally in Aftenposten in 1996. And at that time, Aftenposten had a good enterprise deal with Sybase. And that was before the sales guys in Sybase had heard about the internet. So basically, the deal was a small piece of paper saying Aftenposten can use any Sybase product they want for as long as they want. So, they have renegotiated that deal now, but that's why we have Sybase. And the Sybase database, the schema, is originally from those days. But as a brand, Finn was launched in 2000 with a major .com party. Anyone called Finn in Oslo was invited to Grand Hotel, driven in a black limo. They had rented the laser show from Pink Floyd, and there was a commentary in the newspaper, FINN.no raped the Oslo city center. That was .com, and the bag of money was empty after that party. But it still managed to survive. Thanks to some visionaries in the board and management of Schibsted and Aftenposten at that time. In 2006, I launched FinnCart outside the monolith. It was an experiment, and that was okay as long as we didn't affect the monolith at all. And we had Fast as the search engine, and we wanted to show all ads in the map. So whenever you move the map, we do a search. But Fast had the business model, you paid for queries per second at that time. So adding, let's say, 50 queries a second would be 10 times as expensive as what we had already. So that didn't work at all. So we loaded all the ads into memory on startup and had a huge machine of 8 GB RAM, probably. And it just worked. But that was our first experience doing something completely on the side of the monolith. And that was either DevOps or Cowboy. We deployed whenever we wanted because it was a very small team, 2 persons. But for the core business, in 2009, what we called modules were separated out. And someone had found Thrift, which was open source, thrown over the wall by Facebook. So it's not updated much. And we separated what was easy, the login code and the user account code. Because it was quite recent, it actually had a package in the code structure, but we did not separate the database. But it helped those teams or the people looking at login and user to deploy whenever they wanted. We also put out some reference data, and so the way these were separated out was that you took the in-memory codes we already had and made them over network, adding 100 times the latency. So, which was also what EJB, remote EJB tried to do. And I think Microsoft had some similar technologies, which didn't scale that well. So we added huge amounts of caches everywhere, and then it quite worked, but no one knew how to refresh attributes on search because they are cached somewhere, we don't know where. Wait till the next night, we'll reboot. Yeah, but we solved that we had to change the code and wait for the deploy of the big monolith to get anything done. That was worth solving. So in 2012, there was a project actually initiated by the CFO. Because money was pouring in, that's very good, but we didn't know where we earned money. We would just notice that money is running in. So he decided we need a new product catalog so we can attribute all the money flowing in to what product it actually belongs to. And this was the days of REST and proper REST, maturity level 3 or higher on the Richardson maturity framework. So this caused many services and many redirects and calls. So we really started building microservices at the time, or modules as we called it. We also had a skunkworks called Mobile Web because we were very late to the mobile party. But some product person said, we need to be present on mobile. Okay. So we had a small team making an API, encapsulating all the legacy code, and a small team using mBricks, mBlocks, something like that, that detected or sniffed your phone and so on. So they started with that in 2006, but around 2012, it got attention on the top. So in 2014, our front-end architect, he was so tired of Java server pages, JSPs, in the monolith. It was horrible technology, really old, very hard to get anything done. So he said, we must freeze the legacy. And everyone was quite tired of working with that repo. So yes, it was rubber stamped by the technical leadership, and we're freezing the legacy. And we found out that our modules now have a name. It's called microservices. Yes, we're buzzword compliant. We were very happy. And so the hero of the year was Sam Newman. So and someone found money to invite him, and so he held microservice workshops. And we had a group, an architecture board, architecture forum, making a list of requirements. What is a microservice? And I dug this up from old documentation when I prepared this talk. And I'm very happy to find out that we actually, on new stuff, we actually can check off all the points, more or less. So that's good. Yeah, and especially the last point, perhaps don't crash even if dependencies are down. That's very important when you have 500 microservices. And that was Hystrix. I presented that in JavaZone some years ago. But basically, I and another friend had used it in our project, and it was great. It implemented the patterns of circuit breaker and similar from the release it book. We presented it. You get that nice dashboard, and if someone else's stupid team is going down, you will survive. We presented that and posted link to the code just on a tech talk internally. And a month later, almost all teams had done it because the value was obvious at that time. And after that, it really rolled by itself. If something went down and they didn't use the circuit breaker pattern, almost all teams around would just, you're not using Hystrix, are you? Woohoo! Fix it. And so that just rolled out. No need to push it down to the teams. And by now, Hystrix is obsolete or finished. So, but it still works for us. But Netflix has abandoned that as an ongoing project. But synchronous calls to a service that calls the legacy database. That was really what we did most of at that time. And in 2014-15, we got a new enterprise architect coming from Telenor. And he wanted to have our own Deathstar, which all microservice companies presented at that time. So by Zipkin, we managed to get this dependency tree. And you could argue that we had a distributed monolith. Even though we could usually deploy independently, you didn't need to coordinate deployment. So it wasn't as bad as it could be. If that's a... The heroes of that year were Udi Dahan, Eric Evans, and Fred George. Udi Dahan is perhaps known for many of you. But for us, being a Java shop, we didn't listen to people who knew .NET because that's a different technology. It's Microsoft. But it turns out he had very interesting ideas. So he was also invited. We had Eric Evans, and especially strategic DDD, thinking about what is actually important, what is our competitive advantage versus where is it acceptable that it just works. Fred George had a workshop which is very interesting. He is doing asynchronous nano services. And 63-year-old guy looks like Santa Claus and is very aggressive on doing cool stuff. So in 2016, we had all the direct customers, so private customers, Target, for instance, over on the new stack. And we were integrating over Kafka, event-driven, message-driven system. And when they were showing the progress report of this project, they said 95% of the volume of our ads are over. We are nearly finished. But if they wanted more people to the project, they had another view. Only 30% of the revenue is running on the new stacks. We need more people. Which basically means that a status report you can usually frame whichever way you want. We made data from the legacy database available on Kafka. So by some trigger magic, we published all the changes in Sybase on Kafka, which means that you can get data streamed into your application without being dependent on Sybase being up or scaling for your purpose. And we launched the responsive website, and it was supposed to have 0 database connections to the legacy, only using APIs. Of course, when I looked into it last year, that wasn't really true anymore, but it's mostly true. So it's a principle, but it turned out to be not 100% true. We also had an out-of-Sybase project. So by summer, we are going to cancel the license, save 2 million Norwegian crowns, and just do it. And it had traction for a quarter, and the progress moved a little bit. And the business asked, why are you doing this? We can give you 2 million if you want. We need you to develop this new cool product where we will earn 100 million. So it was cancelled. But the direction was still clear. We want to move out, but not now, or when you have time for it. And we have continued to do that, mostly using these 4 techniques, or looking for asynchronous dependency on data from the legacy, and mappings. Or, if possible, just doing it outside, because you are doing something new that didn't exist, a capability that didn't exist in 2004, you just build it on the outside. Another strong force is that we wanted to move to the cloud. So we are running now private cloud, as in we have 60 nodes run by IBM, on which we run Kubernetes and OpenStack. So in the tech strategy, we said we want to be ready to move to the cloud. We don't want to bake images the old-fashioned AWS way. We want Docker. So we made a deployment platform around Kubernetes, integrating with our old pipeline stuff. And now we have over 90% of our applications running on Kubernetes. So we believe that a move to public cloud will be easy, or at least easier. But we still think it will take a year. Our professional customers. So when we ask people, are you happy with Finn? Many people say, yes, that's very good. Usually top 3 on the rankings of known brands and happiness and trust and so on. But if you ask some of our professional customers, they have tools from 2004. They don't think Finn is the world's most innovative company. But so in 2016, we prioritized that. Last year, we actually got a team to make a new business center. So now it looks good. It looks at least 2016. And their task is really to make it be good for the customers and fetch data where they need it. But hopefully, they will also clean up on the way. New ways of packaging, bundling products is a way to earn more money and, of course, deliver more value. And 2018 was the year of GDPR, probably for some of you as well. So here is, on the right side, you see the principal drawing of the system with the big database, 128 Postgres schemas, and the Kafka cluster exchanging data. And what was very interesting with GDPR for us was that our event-driven, asynchronous microservice architecture really helped us implementing this. So Schibsted has a common privacy broker for all the brands. So even if you go to VG or Aftenposten and you follow the long links there and you want either delete me or I want to see my data. Finn, we get a request from the Schibsted system going into our privacy broker, which publish on Kafka, an event. User ID 1337 wants to delete everything or wants to have a takeout. All domains that have personal identifiable information, which is most of them, will then listen to this topic, do whatever they need, and call back when they are finished, and within 30 days, I think. And actually, some teams have manual processes here due to partners not really being ready to automate GDPR takeout. So please don't press takeout if you don't need it. But so almost all teams, so in the report to the top, I think 50% of our resources are working on GDPR. But they weren't doing that at the same time and all the time. But many developers were touching onto GDPR, but asynchronously. They could do it when they had the time. As long as the APIs or the topics were decided, they could implement it when they had the time, but before April 1st, so that we had time to fix bugs before May 25th. But there was still an elephant in our room, or in the data center. Because even though we now have created more and more databases outside the legacy, the traffic to Sybase did not go down. It grew. With the growth in traffic on Finn, it's 10-15% even this year. New integrations, new synchronizations led to a scaling problem. A full scan of some of our major tables could take 24 hours. So you don't want to do that. And just a small jitter in the network or disk write performance was really visible in our dashboards, causing increased latency. And the hardware was end of life. So now we learned from Kotter about change management that you need a sense of urgency to get anything done. And this started coming up now. Spark Solaris is not a platform you want to, you can't really take that on your arm and go to Amazon or Azure and say, I want to run this in your cloud. So we need to move out. And we had talked about that for many years. At least 5-6 years, we want to move Sybase onto Linux. But the experienced database people in the organization said, this is going to take 48 hours of downtime. How hard can it be, I thought. But no, it really takes 48 hours. So, and that was the accepted truth for many years, also because it still kind of works, as long as no one did a full scan. So if you did a search on a high level, so let's say you're Oslo Kommune, and you, in your back office tool, search for all ads by Oslo Kommune, you would take down Finn. Because it would do a recursive SQL, creating locks, table locks in the ad table, and everything went down. That was quite bad. So we tried to have some, if this query looks nasty, let's not do it. But so actually some of the downtime in those days were caused by stupid users pressing the wrong button in the back office. So we want to avoid that. And so since we finally had the proper sense of urgency, we sat down last autumn and said, last fall, we need to fix this. We need to find out, is it really 48 hours? So the infrastructure team did a test port, and it was about 48 hours, moving from Spark Solaris to the Linux boxes that were actually purchased 2 years ago. So it has been tried, running on SAN with spinning disks. So I said, I learned Amdahl law at university. We need to find out what can be parallelized and improved, and what is actually serialized and slow. And it turned out, so you might probably not know that, but Spark Solaris is running on big endian architecture, and Intel is on little endian, which means that when you move this database from Spark Solaris to Linux, you need to flip all words, all data in your database must be flipped. So it means you need a full scan of all the data and flip the bits. And that takes some time. And then any index, typically indexes, that's binary pointers to something. And when you flip all the bits, also these indexes are invalid. So not only we need to do the endian conversion, we need to rebuild all indexes, and we need to do some database consistency check, DBCC. That's a tool Microsoft also has, I think. So we needed to do the endian conversion, but the rebuild of the indexes, that we could improve. We noticed that SAP has now bought Sybase, and they have made tools for their ERP customers to move from Solaris to, or from whatever, to Linux. And they don't use official tooling at all. They have made their own, actually going through CSV files. So they dump all the data into CSV-ish things, move it, and import it. We didn't have to go that far, but what we did was testing lots of things, Linux kernel configuration, database configuration, turn off any kind of security, waiting for disks and those kind of things, and parallelizing all the index rebuilds, etc., etc. And we managed to get it into a 6-hour window. So in 8 hours, we could migrate. And okay, 8 hours is a little bit too much for the business, but on the other hand, if you get 8 hours unscheduled downtime during peak, that's worse. But then very late, we considered, hey, there are some cool, nice NVMe SSDs around. Let's try that. And then we went down to 4 hours window. So 5th of June, we had a 6-hour window during the night, and we couldn't really remember the last time we worked through the night with scheduled downtime, which really wasn't downtime, it was degraded. So you could surf FINN, but you couldn't actually change anything. So we had 30% lower page view through that night compared to a normal night. And I think HR wrote an article on this yesterday that was posted on LinkedIn, and I got some giggles from a few friends because HR didn't get all the details correctly. Yeah, so this is the graph of I/O wait before the change and after the change. And this quote I should have seen 10 years ago probably. Adrian Cockcroft said in 2008, spinning Rust is dead. Sounds are now a complete waste of time. Someone should have told our infrastructure people in 2008. But now with enough memory and SSDs, a database of a terabyte or two is nice and funny. You can run queries and joins and whatever, and a full scan takes, on a cold rebooted Sybase, takes now 10 seconds of a table that took 24 hours when running under load on spinning Rust. So caches and good fast disks, that's great. Yeah, so that's a major milestone this year. We migrated off Spark Solaris, which means that we're now ready to take everything we have and move into a cloud. And that will probably be the fall priority for on a tech basis. So it's time to harvest and conclude and make something tasty of grapes. So what did we learn? This did not go as fast as we dreamed. As you remember, we thought we would get out of Sybase within 6 months, some years ago. But now we have a roadmap and a direction, but we also accept that we need to make it better to live with what we have already. And by encouraging and enable teams to make services on the outside of the old monolith, we have created lots of new features and probably new technical debt as well. What you need to ask yourself, if all your clients, so as in downstream clients, APIs, consumers, need to rewrite to realize a benefit, when can you realistically be finished? We sometimes meet teams that are doing something, a central component, and we haven't written this. This is legacy code. We want to rewrite. We need a nice API. Okay, what is the consequence? Yeah, all teams have to rewrite their use of this. Okay, what's the value? We get a nice architecture. Yeah, so it might still be worth doing, but it's very expensive. and you're causing work on all the other teams. So that we need to talk about at least. And for us, the Accelerate book, the metrics there on good DevOps are very good, and we think they are good for us. In the book, they argue that there is a causation almost between if you have these good numbers, you're also a good business. And I'm not sure, but I don't think it's bad to be able to have an ID and deploy it tomorrow, deploy it 100 times a day, and having a mean time to restore of a crash or a problem of 30 minutes. You're probably better off than if it's a day to restore a service, or if you deploy every month. So in other parts of Schibsted, the Accelerate book, the metrics there is being pushed, being used to look at how we develop our developers and our systems to perform better. But the biggest reason why we haven't slain the monolithic dragon is that there hasn't been a really strong business need to get out. So as priority 3 or 4 or 5, we will work on it over time, but it won't be done in half a year. And probably that's good for business. We could say, stop everything, we will move out in a year, and not do anything else at the same time. But that's probably not good for users or the CFO, so it won't happen. What would we have done differently? Controlling expectations. We have a complicated system. We need to accept where we are. In a way, we have been in denial. Oh, IAD will be turned off soon. We don't need to fix it. We don't need to fix security holes. Nah, it takes a long time to rewrite everything. I think we should have used more lipstick to offer better, especially for our business users, better backend experience than what we have had until recently. Sam Newman recommended that you consider separate the database first. That's the hard part. And I wonder what we had managed where we would have been if we had done that. It could have been a great success, or it could have been a disaster. I'm not sure. But at least the way splitting the services first, but joining in the database, we got started. When teams are moving out, there is and I know this by myself, you can get this time we're going to do it right, or second system syndrome, where you're going to fix everything that's wrong, and every single feature ID you've had the last 3 years, you're going to put into the new system. That will not make you meet deadlines. We've also read in blogs that Netflix and Amazon has used at least 10 years to get out of Oracle database. They made a big show last autumn at reInvent by shut down abort on the big Oracle database. But Larry Ellison still claims that they are lying, but I don't know. But it takes time. That's the point, and it's often where your money is. But now we do have a direction and a roadmap to get out, and the developer morale around this is very good. But also, since we are running this database in a more serious way, taking care of it, we have a small team taking care of the monolith, having the authority to actually do bug fixes if they want to. We think we are in a good position. But then someday the dragon will go to sleep, I think. And then we will have, of course, a different dragon, which is 1,000 microservices. That will be a new talk in 5 years. So come back. So I think I would like you to remember that not all of a large system will be well designed. And start from where you are, what you have, and what your customers have. We have systems integrating with 40 partners, and the teams owning the integration, they want to fix it. There is something wrong in this integration. The price field has a wrong type. It should be stricter. Yeah, that's a good idea, but you need to convince 40 partners where perhaps half of them has fired their developers 10 years ago when they made the system to actually change it. So actually, Eric Evans says the same. Start with where you are. What is the system you have? Because that's the system you're going to change. It's no point of painting only the unicorn rainbow scenario. And finally, what is the problem you are trying to solve? If you don't know that, any solution will take you somewhere, but probably not where you want it to be. Thank you for attending. And if you want to ask questions, feel free. But you can also take the applause. We don't pass a microphone, so just speak out loud.
You can also repeat the question, but are you using Kafka streams and the principles from Udidahan? Are you using the Kafka streams instead of NService bus?
So the question is, are we using Kafka streams? Are we using NService bus? Are we using the principles of Udidahan? So we are not using NService bus. We probably could now on .NET Core, but we haven't tried. But we use Kafka, we use Kafka streams, and we use homegrown orchestration state machines based on the principles of Udidahan, especially in the life cycle around payment, ad fraud, content review. That's quite complicated state machine. And that's really a saga in Udi's terms. The GDPR broker is also a kind of a saga. But yeah, so it's very much inspired by that parts of the system. Actually, when we got this new enterprise architect some 5 years ago, who had been to Udidahan's advanced distributed system design course, he said, "This is the best course I've attended. We must go there." And it was quite expensive, so we sent 10 developers. 5 of the developers thought that was a complete waste of their time. And they were working in domains such as search, some high volume something, recommendations. The other half thought it was really one of the best courses we have attended. And they worked with the business systems, taking ad insertion, payment, billing, discounts, all those kind of systems. So it was really an eye-opener for me. Not all of our developers are working on that kind of system. So, but it's a pattern that is very useful in some cases.
How many developers manage your 500 microservices?
So how many developers and managers do we have for our 500 microservices? The official headcount in technology is now 180, but I haven't really looked into the drill down on. So UX is not counted there; they are counted in product, but front-end designers are there. I think we have a manager per about 10 to 15 developers. And it's a little bit Matrix or Spotify-like, as in we have tech leads without personal responsibility or management responsibility, and we have managers doing managing a group of people in different teams. Yeah, so it gives us a ratio of 3 microservices per developer. But I know a team that has at least 50 artifacts, probably maybe more now, the search team. And they used to be 2 persons, and that was too much for them. Now they are 4 or 5, and I think they are quite happy right now. So at least with the Docker container service style, so maybe it's around 5 to 10 per developer is a maximum. But we don't know yet. 50 per 2 was too much, that's for sure. If you do AWS Lambda style, maybe you can have more, or probably you should be able to have more. But we haven't really tried that yet, and maybe we will, maybe we won't. We're not sure. Yeah?
Yeah, the grand redesign is kind of a common war story in our industry. And it seems like the maps story was very important, where you got your feet wet in what could be considered a greenfield project in many ways. How do you consider that approach versus assembling a tiger team that is going off to somewhere and then they don't have any deadlines, they don't deliver anything, but they are supposed to come out of the cave in 2 years' time with just the redesigned software?
So the question was about the grand redesign syndrome or pattern or anti-pattern in our industry that we often want to do a grand redesign, and whether the CART, the map service we did 2006, which was really the start of, yes, it's possible to do something outside the monolith, versus a tiger team, send them off in a cave and let them come back 2 years later and deploy something. So in the startup days, I ran Ski Info 20 years ago, and there we did, we need a new snow reporting system. Let's go to Hemsedal in October for a weekend and just do it. And that worked very well at that time. We programmed from 10 in the morning to midnight, then we played Free Civilization until 6 in the morning, and then ate breakfast and repeat. That was different days. I'm not really fan of the big throw everything away, but I guess there are situations where it's actually a good idea, but there has been some attempts in ships that in the other classified sites that didn't really succeed that well in, let's do this with a completely new team that don't know the domain, but it's for sure going to be great. Yeah, so I recommend finding out what you have and iterate frequently. And if you do something for 2 years on a different site, you're not iterating frequently, I think, delivering value frequently. I've been organizing the Agile conference in Oslo for 10 years, so you probably know my bias in that respect then. But let's say I was in discussion with Dips for a year or two ago with a developer conference, and maybe for a big healthcare system, it may actually be a better idea to just scrap most things, take the learnings and do it from scratch. I don't know those domains, so I wouldn't make any strong recommendations there.
You mentioned you moved out of JSPs, and so what's your front end on right now? And did you want or did you manage to break it down to microservices as well?
Oh, that's a good question. What happened with the JSPs? What are we doing now, and how did we manage to break it down? So there's probably a JSP somewhere, but not doing anything important. And I think the Java people started using Velocity. The front-end people still said, that sucks. And so let's cut. What we have today is really, we try to have full stack ownership, so a team should also own their front end. And I should have brought a link to that one. We have open sourced our micro front end framework, which we are using, which is called Podium. It's in version 4 right now. And in a way, it's just to me, it's iframes. I mean, I made web in the 90s. This is just iframes, but done with JavaScript and solving the bundling problem for you, and also solving that you can have different teams can use different technologies in different parts of the page. But of course, if you use Angular, React, and Vue on the same page, you will get a huge payload. So it's probably not a good idea, but it's doable. And so I think most teams gravitate towards React today. And but we do have a front-end component system called Troika, which is, I think, the OOCSS movement was the origins of it, which means that you can actually use it in whatever technology you want, but they are also making React components now. Accessibility is a very important aspect for Finn, so and we do have a few talks on accessibility on conferences. So the Troika components are accessibility tested. So teams can use something else as long as they conform to the style guide. But if you choose to use our Troika components, they are accessibility tested, and you don't really need an HTML, CSS hacker on your team. You can do front end regardless. And by accessibility tested, we take that seriously. We have a person who is blind on that team. And it's really amazing looking at him programming and doing things. There are some videos on him, I think, to Martin on the web. It's worth looking at. Did I answer your question? I think so.
Yes.
Yeah. Hope.
Actually have another one.
Let's take the neighbor first.
What is your strategy when designing microservices? I mean, do you actually spend time to build a strong domain model, or do you want to keep them quick and dirty? Because you want to make a tape, they are small, so it's not going to be that much of a problem. Do you see any value in having a very strong domain?
Yeah, so the question is, what's the strategy when making a new microservice? Do we make a strong domain model? And the answer is, that's up to the team. Actually, so the team will decide whether do we need a good domain model here, or can we just scrap something together and fix it later. But it really depends. So typically the billing lifecycle teams, they do have quite okay domain models and are talking about domain-driven design when they are maybe not drinking beer, but at least that's a topic in their teams. Whereas the search team, they are doing something in a completely different way. They're not building traditional domain models, at least, even though you could argue that it's a domain model, but it doesn't look like one, or at first glance, at least. But our principle is really that teams should be as autonomous as useful. So they can make lots of decisions themselves, but of course we don't want them to do the wrong decisions. So that's the balance.
With 500 microservices, how do you ensure discoverability and ensuring that two teams doesn't create the same service because they didn't find a service that did the job they set out to do?
So the question is, with 500 microservices, how do we discover them, and how do we know that two teams are not doing the same thing? The second question first, we don't know. So don't repeat yourself is important within a service or a team or domain. Across, we don't try to do much reuse there. But also, we have organized the teams around domains. So in theory, if the map team and the recommendation team is doing something very similar, it probably is not similar over time, so it's okay that they are doing more or less the same. For discoverability, we used to have our own internal service discovery called Green Pages. In Kubernetes, we just use the DNS. So discoverability is, I think, as much as we need. We don't have any strong there. And often microservices are working together within a domain. So they are tagged with the domain typically. So you can see, and they have some naming standard. But we don't really have a big service catalog. And but we do have some strong, so the classified add is a very important concept in our system. And then there's a public topic, and there are these two add lookup services you want to use if you are doing a synchronous request. So we have some major things that are important for almost all teams that these are the ones to use. And otherwise, you probably need to be good at networking to have speed if you want to use existing things from other teams. We have 30 seconds for a very short question. Have you experienced any major drawbacks on moving to the cloud? So we are still on on-prem cloud, and the disadvantage of that is that the lead time for new hardware is still 3 to 6 months. That's why we want to move to a public cloud. We do already have our data warehouse on Redshift, and we have recommendations. It's spending a few 100,000 crowns a month with Google for recommendation stuff. For now, the people are especially in infrastructure, are so tired of the networking and the problems with the old data center that they don't see any disadvantage at all moving to the cloud. But as you know, some Netflix people said that we don't run Chaos Monkey anymore. AWS is Chaos Monkey as a service. So we'll see. Let's take that one next year. How we moved to the cloud and stuff went down the toilet or something. Or how it was a great success. Thank you for attending.